Hi, I wanted to give you a couple of quick videos on this program, the manipulating bit sets and set operations. And one of the reasons why I wanted to spend some time on this one is most people, especially after Prolog has hurt their brains a little bit, come at this and they say, "Oh my goodness, what's going on here?" So first, I'm going to go through and we'll talk a little bit about what a bit string is. In this case, all we're really going to do is we're going to take an integer and we're going to treat it like a bit string. Um, the integer, by using integers, we actually have access to individual bits within the value because if they work with what are called the bitwise operators in different languages. Um, what we will do is we'll take the positional notation of the integer value, and any bit that is set is going to indicate that the corresponding digit in decimal is in our set. So we've got the decimal digits 0 through 9 are the set that we're actually using. And we're going to be setting a bit to indicate each one. So one of the ways to help is to actually go through and take a look at the documents that are there. One of them in particular, this first one, is bit strings. As you can see, I've got the bits numbered 0 through 15. This is for a 16-bit integer. We actually have 32-bit integers, but that's really not too important because we're only going to be using bits 0 through 9. Now, you might be wondering why we call them that. It's because we use positional notation when it comes to representing numbers, both in base 10 and in base 2. In base 10, this rightmost position would be the ones position, which is 10 to the 0th. While here, this is actually 2 to the 0th, which makes it still our ones position. The next one in base 10 is 10 to the 1st, which is the tens column, and we would put a digit 0 through 9 there to indicate how many tens we have. Here with binary, with our first bit, that is our twos bit, or 2 to the 1st, and of course we would put either a 0 or a 1 because that's all we have in binary. So each bit position is actually a power of 2. We number them by the power of 2 that they represent, but we're not really going to use the power of 2. All we're going to do is we're going to go directly to, for example, bit 7 and say, if I want this one to be a 1, I'm going to put a 1 there. So our initial set will be an integer value of 0, which means all of the bits will be 0. And we can just declare that as an integer value of 0 or an integer value and assign 0 to it before we read in the values of our set. I'll talk about the algorithms for both reading and printing next time. And the third video, we'll take a look at the operations that we have. So here, this is just an example. It's saying that if, for example, I shift the bit 1, or pardon me, the integer value 1 over 0 positions, this is what it looks like in binary. It's a 1. It's at the integer 1. If I take the integer 1 and I shift it 1 position to the left, this is what it looks like in binary. And as you can see, the 1 has moved from the rightmost, the ones position. It's now moved to the 2 position, the twos position. We're going to use that property to put a bit anywhere from either bit 0 up through bit 9. So that is our representation here. And let's see, some of the things that we can actually do to set a bit. It doesn't matter what the bit was before, we can set it. And the way we would do that is given the original value of the set, and I've got, I just happen to have the value 0 here, but it could easily be a 1. In order to set the bit, whatever number I type in, somebody types in the value, this is an example of 5, then I would shift the integer value 1 to the left 5 places. Well, as we see, that's this number right here. And we're just using that same number down here. We would do a bitwise OR, and our result would make sure that there's a 1 in this bit position in the result. So if I do a bitwise OR, and I've got the operation for that here, then if I do that bitwise OR, I guarantee that there is a 1 in this position. Now the other thing we're going to be doing is we actually have to be able to test and tell, is that bit a 1 or is it a 0? So we use a bitwise OR to make it a 0, and we use a bitwise AND to see, to get a result. Is it or is it not a 0? So here, if it is a 0, the result of an AND will be a 0 in that position. And because all the other bits here are zeros, my resulting output, the number here, is going to end up being 0. So if I do a test and that bit is not set, I get a 0 as a result. Now if I do a test and the bit is set, I do not get a 1 as a result. This is a bitwise, not a logical operation. Instead, I get 2 to the 5th, which is 32. So I can't check to see is it equal to 1. But in most of the languages that we're using, I can just check to see, is it greater than 0? And in fact, as long as I'm not in Java, I don't even have to do that. I can directly test this result, and if it's not 0, it's going to be a true value. So here, to set a bit, all we do is if set A is the name of my set, then to set a specific bit that is or value to add it to my set, all I have to do is shift 1 over by the value that was typed in, shift it to the left, do a bitwise OR, which is a single line here instead of 2, with the set that I originally have, and the result will be just like this, what you see up here. No matter what value I had in this position before, a 0 or a 1, an OR will make it a 1. And then for testing, for example, when we print a set, this is what we'll do. We'll check to see, is the bit at, and we'll have value go from 0 to 9, is the bit at 5? So here, if value is 5, we can check. If I shift 1 over 5 places to the left, and I AND it with set A, if the result is greater than 0, then the bit is set, because 32 is greater than 0. Or 1 if I was checking the first bit, or 2 the second bit, 4 the third bit, 8 the next bit, 16, 32, 64. Anyway, the note here, I need to add Python to this list because you can do the same thing in Python. In Java, you will need to check right here, is it greater than 0? And that will tell you whether or not the bit is set. Java does not treat integer values as Boolean values, whereas C, C++, and Python all do. And so that's basically it. We'll have a function that will read in the set, and if it reads in a value between 0 and 9, it will set that bit. And we don't care if it's a 0 or a 1 already. If they type it in twice, that's their bad, but we'll just set it to a 1. And then for printing, if I get a value that's greater than 0, I have a 1 to print, and if it's not greater than 0, then I print a 0. So that's all we need to do. The next video is going to take a look at our pseudocode for both printing and for reading in the set.